What's up, everybody? Welcome to the first episode of the Onlycans series, Deeper Please. We are calling it Deeper Please because so far we've only given you tips. So now we're going to really dive into it. Today's episode is going to be about quality assurance. Quality assurance is something that is a very big deal in the brew house. The way I always explain it to people is we could spend 3 years writing a recipe. We could spend 2 months sourcing the ingredients. We could spend a buttload of money on Madagascar vanilla beans. We could have a beautiful brew day that was a collab. We could spend, another 2 months in a fermenter. We could have an amazing transfer with a super low DO. We could get it into the bright tank. But when it comes to canning day, if we don't take our time and care, then none of it mattered. Absolutely none of it. And because of that, from the other angle, that's why we always say at Codi as well, I'm not a brewer, but I sure do make them look good. Because we can take a beer and we can hold its integrity if we pay attention to quality assurance. Because quality assurance, the way to think of it, is the best offense is a good defense. And when it comes to all those quality assurance practices, it's simple things like making sure your machine upkeep and care. Whenever it comes to things like our Codi filler, if your cell phone's being a dick, then you're just gonna go get a new cell phone. Or if your, other electronics and various things we use around our house, like if your Ninja food processor starts being a dick, you just get a new blender. But when it comes to things like our car or our canning line, we don't have that option. We have to maintain, and we have to keep up. We have to stay on preventative maintenance, and we have to take ownership of our equipment. The Codi is a great canning line, and as long as you take care of it, it'll take care of you. When it comes to taking ownership of our machine, what I mean by that is there's a specific set of tools that we want to have on hand. Obviously knowledge is the number one tool that we want to have on hand, of having the knowledge of how to care for our machine and how to have the machine running in pinnacle operating conditions. But when it comes to actual physical tools to have on hand, micrometer is number one. Staying on top of our spot checks and our seam checks. A set of calipers whenever we're measuring, the body hook and the cover hook. Being able to get in there with some calipers to see exactly what's going on. The force gauge that we're using to check our spring pressure is an invaluable tool to make sure that we're staying on top of that. A dial indicator to be able to do our wiggle test and to be able to check various things around the machine to see that thousandths run out that we might be getting on various elements of the machine. And the last couple things would be a file and some wire cutters to be able to do full seam teardowns. One of the things that always hurts is whenever a brewery hits us up in service and says, hey, we're getting some leakers. And we say, all right, let's talk about our most recent seam checks. Where have our seams been coming in at? We say, oh, we don't check our seams. We got to stay on top of that. Seams that we're staying on top of as far as like doing our standard seam checks. The second something starts to run out or move or shift, or we start seeing trending data, we can fix it way before it ever becomes an issue. But if we just run for 8-9 months straight and never check a single seam, we never do a spot check, we never see what's going on, then all we have at our disposal is just to kind of hope for the best. So having all those tools, those micrometer and the calipers and the wire cutter and the file to be able to tear down seams at least once a pallet, hopefully more. I've been to multiple breweries that do one an hour. I've been at breweries where they're tearing down 6 cans an hour, and everywhere in between. But staying on top of that and knowing exactly where your finished goods are landing is going to be the difference maker of whether or not you're going to be recalling pallets. staying on top of your machine as far as your op rollers and your lifter bearing, and your table, the table itself, as far as the linkages and the air pressure and the spring pressure and the pin height and all of those things playing together to make sure that we have the absolute best possible outcome for finished goods. So as far as quality control, let's start out with the seamer. And I've mentioned a couple times at this point the wiggle test. What is the wiggle test? Well, when we're doing a wiggle test, we're using that dial indicator, and we have our lifter linkages, our lifter bearing, our op1 and op2 roller, and then we have our chuck shaft. And those are the 5 areas that we are going to be staying on top of and doing an actual wiggle test, seeing if the bearing integrity is still there. All of those points, so the linkage is going to have its own tolerance. The lifter bearing is going to have its own tolerances. The 2 op rollers are going to have their tolerances. And then the chuck shaft as well. We say it has a tolerance, but really, if it moves at all, that's not good. So using our dial indicator to actually check those tolerances and make sure that the amount of movement allowed inside that tolerance window is actually all the amount of movement that we're able to see. You know, when the lifter bearing is moving left to right and seeing if it's wiggling that way, or our op rollers, seeing what kind of manipulation we have on those as well. And then the chuck shaft being able to move around inside of its pillow block. And then finally the lift table underneath. Does it have play side to side? All of those things, those bearings keeping their integrity, are going to make sure that we have the best possible outcome for our machine. And the wiggle test is something that we absolutely suggest doing at least once a week. And the thing about quality assurance, and this is something I haven't necessarily explained yet or really referenced at all, but when it comes to checks like this for quality assurance, we want them to be boring. We want to have a clipboard that's all of our quality assurance information. That's the same fucking numbers written down for an entire page. That's what we want. We don't want to see things walking out. But if we start writing down numbers, you know, say take seam height, for instance, and we've got 8 runs in a row where we're anywhere between 98 and 101. And that's just, those are the numbers we're writing down. Then all of a sudden we have a run where we're getting 97, 99. And that happens for about 3 runs. And then on that 4th run, all of a sudden we're getting 96 to 97. Well, all of a sudden we have trending information. It was boring for about 2.5, 3 months. And then all of a sudden, because we were staying on top of that monotony, we were staying on top of those quality checks, because we were religiously writing down that information, we were able to see exactly, aha, I need to make an adjustment to get my seam height back into spec. And we were able to make that adjustment. Give it here. When it comes to greasing our seamer, we want to do so every run. And I don't mean that we need to replace the grease in our seamer. I don't mean that we need to go through an entire tube. What we're looking to do is make sure that the seamer is always packed with grease. And by always packed, I mean at the end of a run, when the seamer is still warm and still running, we're going to hook up our grease gun, and we're going to give probably about a pump and a half, very slow, smooth movements. And once we see some grease begin to evacuate from the pillow block we pull, then we're good there. And there's no reason that an entire tube of grease shouldn't last you anywhere from 8 months to a year if we're just putting in those little pumps at a time. You know, that grease isn't necessarily the cheapest grease in the world. It's not buying you know, vegetable oil or something. But at the same time, as long as our pillow blocks are packed with grease, there's 2 things that are going to be happening. 1, friction is cut down and heat is cut down. As long as the grease is in there, it helps with those bearings being able to roll. The other thing is, as long as our seamer is packed with grease, then water can't be present in there. Grease has displaced all of that area and made sure that water cannot be present inside of our pillow blocks. Once water gets into the pillow blocks, we do not have a ton of time for that chuck shaft bearing to retain its integrity, and we're all of a sudden going to see some movement on that, which is absolutely going to affect our seams, which is absolutely going to create leakers, which absolutely is going to create buying back pallets from our distributors, and we don't like that at all. Our next area is going to be staying on top of our op roller distances and making sure that those checks are going forward monotonous information, getting the exact same readouts every single time that we measure. Depending on our Op1 roller, we're either going to be setting it at 14 thousandths or 9 thousandths. And then our Op2 roller, we're almost always going to be setting around 3 or 4 thousandths, depending on what kind of seam measurements that we're getting on our cans. One of the things that we preach a lot in the service department here at Codi is we want to let our seam measurements really dictate the setup of our seamer. So when you go into our dictation and all of our materials and all of our setup manuals and things like that, we're going to tell you where the defaults are relatively going to land. And when you're setting up your seamer, where those adjustments are going to be. However, at the end of the day, where we're going to truly set those adjustments when it comes to spring pressure, and pin height, and Op2 distance, and Op1 distance, and all of those things, what actually is going to make the difference is when we're measuring our seams, where are our seams measuring in at? What kind of measurements are we getting? Running a spring pressure test. When we're running a spring pressure test, once again, we're looking for that monotonous information. We're looking to get the same measurement every time. But spring pressure, a spring is just a mechanical device, and the more you push on it, the more it pushes back. So when we're adjusting our spring pressure, when we're making an adjustment to that 1/8 Allen bolt down through the center of the lifter, when I turn it clockwise, I'm going to be applying pressure on that spring. When I go counterclockwise, I'm going to be reducing the amount of pressure on that spring. Well, that spring pressure that we have there, whenever the can is lifted into the chuck, that spring pressure is making sure how seated into the chuck that can is actually getting. If our spring pressure is too high, we're going to see things like buckling, and we're also going to see seam heights be really high, but we're then going to see with our countersink and our cover hook and our body hook, we're going to see an overlap that's really thin. If our spring pressure is really low, then we're not going to see the can getting seated into the chuck all the way. We might start to see things even as bad as deadhead skidders, where the can just doesn't want to seam inside the chuck whenever it gets in there. So staying on top of our spring pressure and using our force gauge to do so. And right behind that would be checking pin height. Doing the two back to back is absolutely the way to be going about it. Checking our pin height based on the can and lid that we are using. You know, the difference being, we were talking about this yesterday in service, going from a crown end to a ball end could be a difference in pin height of 34 thousandths. That's a huge difference. Because one of the things we talk about a lot is on the filler side, we can kind of fudge it. You know, we can use the 16-ounce pinhole to do 12-ounce sleek cans. And we can manipulate and we can kind of fake it till we make it over on the filler side. All we're looking for is just to get a seal on those cans, let's get them filled. But when it comes to the seamer side, we don't have that opportunity. We're dealing in thousandths of an inch. And we don't have a choice but to be perfect. You know, usually we have a 3 thousandths tolerance window that we're working inside, especially with pin height. And once the pin height starts to get outside of that, we can start chasing our tail and going in circles, trying to adjust our op roller, or adjust our spring pressure, when in reality, the can is just not getting seated into the chuck based on our pin height. So staying on top of that force gauge and that pin height gauge, making sure that those are coming out of the toolbox and being utilized regularly is going to make sure that we stay on top of any leakers or any horrible situations that could arise through that. Finally, the last thing we want to talk about is finished goods testing. And this is actually doing seam teardowns on cans themselves. Probably the thing that we suggest the most coming from Codi is that you're tearing down a can at least once per pallet. And that's doing a full seam teardown. Whether you have a Quality by Vision or CMC Kunky, or a device that is actually doing your seam teardowns, or you're using a file wire cutters and doing it manually and doing a full seam teardown that way. Whatever your process is, that is absolutely what we suggest, is at least one can per pallet doing a full seam teardown. So if you're doing 16-ounce cans, that's going to be once every 80 cases. If you're doing 12-ounce standard cans, it's going to be about once every 100 cases. If you're doing 12-ounce sleek, that's going to be about once every 80 cases. Now, obviously, different facilities are going to stack their pallets differently, but pretty much across the board, let's say 1 in every 100 cases, or 1 in every 80 cases, somewhere in there, we're going to be tearing down a can and checking our full seam measurement across our seam thickness, our seam height, our body hook, our cover hook, our overlap, and also our tightness ratio as we're doing those cans. One of the other things that I love doing is just while I'm running my filler, about every 20 minutes or so, just doing a spot check. Pulling a can off the line that just came out of the seam, using my micrometer, checking my seam thickness, and checking my seam height. Everything's looking good, right back on the pallet, and away it goes. Doing those spot checks every 20 minutes, grabbing a can off of there and looking at it, that can honestly give you a giant clue. Not terribly long ago, I was at a brewery, and we were doing spot checks on day 1, and we're doing spot checks on day 2. And after the end of day 2, we were like, you know what, let's make a little adjustment to the Op1 roller. I think that's going to get us, way better in spec of what we want to see. So we make an adjustment all the way at the end of the day. We run some water cans. Hey, I'm really liking those seams. So we fire up the machine on day 3, this last day of the startup. We're running the machine. Everything's looking good. About an hour into that run, doing our spot checks, staying on top of it, we started to see trending data. All of a sudden, our seam thickness was getting wider and wider and wider, and our seam height was coming down and coming down, coming down. And it got to a point where we went, stop the line. And sure as shit, that Op1 roller, when we had adjusted it, we didn't tighten it up enough. And as we had been running, 20 cases, 60 cases, 70 cases, as we'd been running, that Op1 roller started walking itself out and it was not where it needed to be anymore. And because we were doing spot checks, we were able to catch it well before it ever became an issue. And we were able to get that Op1 roller back in there, tightened down, locked into place where we wanted it to be. And then we were able to start right back up and start running again. And nothing actually ended up becoming of it because we stayed on top of our quality assurance and quality control. And we made sure that we were doing the least. But by doing that, we actually did the most, because now sales has 7 pallets of beer that they don't have to worry about stopping back by a liquor store and them saying, yeah, half those cases you dropped off are leaking. And now we're ahead of the curve. We're ahead of the game, and we can release finished goods that we're proud of and that we can lay our head on our pillow at night and not fucking care, because we did our job. We did the best that we could. When it comes to weight checks, I see things all over the place. Whenever I'm at breweries, I know a lot of breweries that use, whether it be a Filtec or a Hoist or a Waystar or whatever the device is. So in those parameters, it doesn't end up being an issue at all. That they're just letting their machinery do that for them. When it comes to breweries and facilities and packaging facilities that are just using, say, a kitchen scale or somebody's retired drug scale or something like that, in that parameter, I would say that anytime we're making an adjustment to our run parameters, whether it be our fill throttle or pressure drop or our sniffs, that's whenever, even if it's an hour into the run, if we make an adjustment, why don't we weigh a good 10, 20 cans in a row, just to make sure that we're still in the wheelhouse of what we're looking at. But what I always suggest to people, when you first start up the line in the morning, let's weigh probably our first 15, 20 cans, see how our weights are looking. And then as we make adjustments, as the beer cools down and we're having to make adjustments to our fill throttle and our pressure drop and our sniff, as we have to start to make adjustments like that, then we're going to start weighing cans again to make sure that we're staying ahead of it. Well, when it comes to the packaging team and being able to stay ahead of things and staying ahead of sensory and staying ahead of the curve on our finished goods in general, one of the things I love to suggest to people is at the end of every run, if you're killing a 60 barrel bright over the course of 2 days, then you don't have to do it twice. But I would say every batch, one of my favorite things to do is take 6 cans off the line, and we're going to set them aside. 3 of those cans are going to go into the cold box onto its own quality control shelf. This isn't low fills for the weekend. This isn't for sales. This is for quality control sensory. 3 of those cans are going to go onto a shelf in the cold box. 1 of those cans is going to be stored just in a cabinet somewhere in the brewery at just an ambient temperature. 1 of those cans is going to get stored, say, behind the boiler that is also insanely warm comparatively to the rest of the brew house. And then one of those cans is going to get stored um, outside, even. Somewhere like San Diego versus somewhere like Juneau, Alaska. Obviously, storing a can outside is going to be a little different. But using that third can as somewhere where you can check one other area. Because when we store a can in the cold box, we're going to see the absolute best lifespan and absolute best shelf life integrity for that. But beer distributors don't give a shit about the lifespan of your beer. They just care about the people buying your beer. So it's going to sit in a box truck. It's going to sit in a parking lot. It's going to sit in a warehouse. They do not care at all what happens between getting it from you and it going to a liquor store. So why don't we manipulate these terms? Why don't we take a couple cans and let's see what happens when one of our cans is stored in a super hot area. Let's see what happens if one of our cans just sits at an ambient temperature. And then we can take one of those cans out of the cold box and we can take that can from behind the boiler after a week and we can drink them side by side. And we just did a 90-day shelf life test. We can drink that can that just came out of the cold box and we can drink that can that was stored behind the boiler. And we can see exactly what this beer is going to taste like in 90 days. And one of the other favorite things that I love to do in there is do a couple cycles of cans, one that have horrible foam, and even let them just sit on the belt for a minute before you let them go through the seamer. And then get awesome foam and send those cans through absolute best DO outcome that we think we're probably ever going to get. And then do the same thing. Stick one can with shitty foam, one can with good foam behind the boiler, one can with shitty foam, one can with good foam in the cold box. Take those 4 beers and do a side-by-side test, and you will be absolutely amazed at the can that had good foam that came out of the cold box versus the can that had shitty foam that came out from behind the boiler. Holy fuck, boys. It is night and day difference. And it will make a giant difference whenever it comes to you as the operator looking at your cans and understanding, I don't know if someone's going to be drinking this beer next week. There could be a chance that someone buys this beer, takes it home, it sits in their garage for July and August, and then they go, oh yeah, I forgot I had those beers. What better sales tactic than someone opening up a beer they forgot they had that's been sitting in their garage and it still tastes really good? That's what I'm talking about when it comes to quality control. When we have a good seam on a can and we have good product inside, good foam, there's no reason in hell that people aren't going to be pumping the tires of our brewers because that's who's going to get the credit. But at the same time, our brewers know exactly why they're getting their tires pumped. It's because we did everything we possibly could to make sure that the beer leaving our facilities was the absolute best possible product that we could ever turn out. So thanks for watching the first episode of Deeper Please. We're going to be doing a few of these episodes going forward, just kind of little talks, little chats about different topics. So thanks. We'll catch you next time.